Now I'd like to invite Harish and Abhishek for their presentation.
Lag. All right. I'll give you that task then. So welcome once again. The topic that we'll be discussing today is AI adoption in discrete manufacturing and Indian context. So the theme would be a little more reality-based discussion. There's not going to be any sugarcoating here. We're going to state reality as it is. I had a script ready for this, but most of them have already covered it, so I don't want to take more time. I have other slides to spend time on. I tend to go off script, so 10 minutes buzzer, please. Next slide. Chalo, I'll take it. So here the script was to set the context for your manufacturing operating system. So we're calling our orchestration layer as manufacturing operating system, where you have all of these departments which are again working in silos. So what we end up having is not a smart factory, but then a factory with smart departments. So how do we make this a smart factory is the question. So this is where I set the context. We have evolved through these phases, but I make a very bold statement here saying that manufacturing has changed, software hasn't. So hold on to your seats, I know what I'm talking. So the idea here is, what I want to say here is, the second information is presented to you, what we do is we navigate through menus. We open dashboards, and these dashboards have line charts, bar graphs, and most of the time things are on x-axis, so I have to sprain my neck to read it. And there is a pie chart which has like 20 pieces. So which piece belongs to me? It's very hard to make sense out of all this data. So essentially what I mean by software hasn't changed is the experience of how we consume information hasn't changed. So what's the point of having all this technology if I have to sprain my neck, right? So moving on, here's the challenge of the day. So machine has broken down. Now you're the plant head. Okay, you want to try to approach the maintenance guy to find out why the machine has broken down. Please reach out to him. All right. So the maintenance guy is trying to escape from the plant head. So why don't you try reaching the production guy? Or the IoT or the MES layer. So what's happening here is this is no longer a manufacturing execution system. This is the Tom and Jerry show. Right? This is a reality of what's happening today. And this is just scratching the surface. Because the second you enter discrete manufacturing, each department has their own thing going on. So probably the engineering or the planning team will be like, oh, we maintain an Excel sheet. So all of it is nicely maintained there. And you go to the assembly guy or probably the quality inspection. We have a guy who writes in the book. Oh, right, you have a guy, so very helpful. So what happens is you see that the previous slide itself was challenging. Now this has become 10 times or 20 times more. The problem is, again, what we've discussed today. There is data. We have to create decisions. But if it's disconnected like this, then we're going to have a lot of trouble. So what we are proposing is, all of this comes together into what we call as a manufacturing OS. So you can see machines and people are the center of this. You have data coming in, and instead of all these data pieces going out, we capture that and try to make sense out of it, which is already covered in today's presentation. So I'll spend a little more time on the next slide. See, what I'm about to say is going to make a few people happy, make a few people unhappy. See, but it has to be said. I go something like, no matter how advanced your AI is, the real value is created on the shop floor. Okay, this is our take. So no matter what happens, no matter how great your data is, the value is still created by machines and people. So this illustration basically means that is the foundation. Machines and people are the foundation for this thing to work. Now from that, the systems generate data, which is our backbone, and they move into manufacturing workflows. This was covered earlier as well. So if there is a number, that number only gets a meaning if an operation or a station or a workflow is attached to it. So that's what happens in manufacturing workflows. And importantly, imagine that there's a line here. So this is our OT and this is our IT layer. The second data jumps here. Hardware is no longer required. So that's where you have your applications, which becomes your interface for all this. It could be your quality modules, maintenance modules, whatever. And then there is AI. So you see, AI is not at the foundation. It's much higher up. What that basically means is, unless there is good data, this will not be able to compensate for that. If there are certain workflows that are not defined in your factory, AI will not be able to assume anything. So all these need to be put in place, and this is very important for today's discussion. All these need to be put in place for this to work. And of course, there's a layer above that, business intelligence. My colleague will be talking about Mitra. So that's our business intelligence engine. And now, see here, data flows. So we mentioned this, I mentioned this earlier, right? So we have a lot of these bar charts, bar graphs. How do I interpret the data? It's everywhere. So we have thousands of readings, we have analysis going on, and there is a visualization there. So coming from a design background, visualization is basically data storytelling. That's another topic altogether. So I won't get into that now. But then if data is, whatever data we capture is visualized in a very insightful way, and there are more ways to visualize more than just line graphs and pie charts. So if visualized in a certain way, it will have beautiful stories to tell, and that is sufficient. I haven't even touched the AI layer. So with just these three, we will be able to address at least 50-60% of the problems, and that is sufficient for most of the MSMEs in India. So this is an Indian context. So I'll be talking about shop floors or companies that make 10 crore revenue to where you have enterprises making 1,000 crore revenue. So probably most of them starting out in the manufacturing sector, this addresses their problem, this solves their problem. And then you have the recommendation engine. We have a success story where we had 1,89,000 entries of service records, and we wanted to make a recommendation engine. If something were to go wrong, how to do it? I tried to upload that Excel sheet on ChatGPT. ChatGPT said, please go home. Because in one shot it said, credits over, tokens were over. So we had to come up with a different strategy. So it's resolved to such a level today that if there is an operator and there is a kiosk on the shop floor, and if you were just to touch a few things, he'll get the idea why something went wrong, and he'll be able to fix it. And that's how we empower the operator on the shop floor. And of course, the next is agents. You can think of agents as colleagues. So there's nothing more to say. It's just that they're so intuitive that it feels like they're there with you. So these are the agents that we have in at AMIT. Oh, I should have introduced myself. So AMIT is the IIoT of the ACE Micromatic Group. So here we have primarily these 5 agents, and they're always talking to each other. So we'll have these use cases discussed in the next slides. So now, before I get into the details of this, so last week I was a little under the weather. So I go to the clinic. I go sit in front of the doctor, and he starts writing a prescription. I'm like, doctor, wait, I have not explained what I need. Like, no, I have AI training, so I can do some prediction. So the story here is, true story by the way. So the story here is, there is no off-the-shelf plug and play solution. There is no off-the-shelf plug and play solution. The biggest takeaway is, every organization needs to understand where they are in this chart. This is called a curve. It's called the digital maturity curve. Now, this has nothing to do with revenue. Let me make that very clear. So there could be an organization making 1,000 crore revenue, but they could be still here in the process of digitization. There could be a company that's only maybe 100 crore revenue, but then they're so advanced in their operations that this layer is actually possible. So the biggest takeaway is, how do I implement AI is not the right question. You need to ask, is my factory ready for AI? Right? With that context, I'd like to hand it over to Abhishek.
Yeah. So am I audible to you? So Harish mentioned about the different layers at which we work on. So like he said, there are different layers at which all the companies operate on. So based on whichever layer you are in, we need to have a backbone of AI. So today morning in the one of the sessions it was mentioned that if without AI ready data, your AI is practically useless. So it is the production data which adds value to your organization. So for that we have an application called Digital Factory. So it's a concept. What it does is that we accumulate data from your entire factory, entire shop floor, be it your machines, be it your PDIs, be it your different stores, FG and all those are accumulated to a digital platform. So what it does is that it lays the underlying foundation on our digital thread to work upon, which in turn feeds our ML models, which can give some insights from that. So this is the base layer at which we work on at the beginning. So now we have a digital foundation ready. Then comes the question of how it is valid for our use case. So for every data, like Mr. Sanath mentioned, I have tons of data in my company. It is all in silos. But when does it actually start making sense? When we try to find some patterns, which AI is very good at, by the way. Coming from ML background, I have been working with AI for a long time. So now here we have data. For the representation sakes, we have given only this touch points. We work with 600 plus touch points, by the way, and all these points are divided across different digital threads. So it's all chaos. So from chaos, we try to establish an order like this. So your data is essentially divided into 3 P's, which is part, process, and product. Excuse me. So what it does is that it gives you a different level of backward and forward genealogy, which is very crucial for traceability. Nowadays, traceability is not just it's not just an option, it's a compliance rule. So all the organizations would want to have traceability on their shop floor. If something goes wrong in your production environment, you need to know at what station it was produced, which operator was working on that, and what processes were involved in that case. Prime example is Royal Enfield calling some 300 or some batches of bikes recently in last year. So that is how they were able to trace. So now we have established digital threads. We have foundation and then we have threads. Now on top of that, we work with different integrations. So manufacturing starts from your manufacturing drawing, engineering drawing. It's a blueprint to produce something. Now the biggest challenge on the shop, one of the biggest challenges on the shop floor is that these drawings are often circulated in a PDF format. So how do you convert that PDF format? Well, theoretically it is in digital format, but a single page of a drawing can have 200 to 300 plus inputs if you are talking about gantry and column drawings, and it is very tedious task. So it takes you need to have a dedicated engineer or a team who will digitize it for you, who will manually mark it and then convert it into a thread which can be ingested by your other softwares. So our solution targets that. So we are able to benchmark it in such a way that we are able to do 200 to 300 plus balloons within a minute, and this is deployed on in actuality. Now you will ask that there are many players who are doing auto ballooning. So what is the value add? So our strength is that our system is able to integrate with our existing ecosystem, and it writes back to the digital thread that we talked about earlier in this slide. So it ties to your quality processes, it ties to your control planning software, it ties to your gauge control plan, etc., which can be circulated directly via traceability digital factory module to the end operator on the shop floor itself. So it's a very powerful thing. So you have a drawing which comes, and within 2 hours it is on the shop floor directly scheduled as per the production needs. So we talked about integration aspect. Now let's talk about the machines, which are the bread and butter of any production line. So when we talk about machines, we have different types of data which is flowing in the machine. No 2 different machines are same. They have their own digital footprint. They have their own different data physiology. A machine might be same, but the type of operations they are running, the type of jobs they are running, the cycle which they are running can differ, and based on that, the behavior of the machine itself differs. My machine, my spindle is supposed to work for 4,000 hours, but it breaks in 3,000 hours. There's a reason for that. You might be abusing that machine. while my machine sometimes, if my production is low, it can run on for 7,000 hours as well. So how do we capture that data? So we can capture it via sensors, but again, only sensor data will not make any sense. It has to be a ecosystem. It has to be a cohort of different types of data which actually make sense. It is all tied up together. You cannot have a one-dimensional data and then expect to forecast something out of it. So coming from OEM backgrounds, we have a data of over 20 years of failures. So we know at what pattern the machine will fail. So our capability lies in capturing that data, be it from sensors or directly from the controllers itself, or we can even put a small gateway device which will capture the data for you. And that all ties down to the predictive maintenance requirements. Now, when I talk about predictive maintenance, one thing that we should address is, do I actually require predictive maintenance? Which type of assets on the shop floor requires predictive maintenance? If you are talking about new machines, then obviously the new machines are again backed by years of failures of data, and any good engineering paradigm says that you work on your flaws and you improve them. That's the basic thing that we learn in our first and second years in our graduation. So rest assured that these things will be covered in your new machines. But the value add lies in the old machines, the workhorses which are there on the shop floor, which have been running continuously for past 5 to 10 years, have been running your critical parts, basically the workhorse of your system. All the new machines are easily integrable. They come inbuilt with some sensors. They are very easy to connect. But the old machines, to connect the machines, it is a challenge. So that is where we add the value. We are able to connect 15-year-old machine, 20-year-old machines based on different layers, different communication protocols, and then we are able to digitize that data. So same amount of data can be captured from your new machine as well as your old machines as well. So it all comes down to a module which we call it as total cost of ownership. It's a proprietary formula that we have developed, based on which we can tell the value addition of that machine itself on the shop floor. So then we come down to the operations part. We have a scheduler. What it will do is, on the current shop floor, one of the most complex combinatorial problem is the scheduling of different parts across scheduling of thousands of parts across dozens of machines, including tons of processes, etc., is a very tedious process. And all that tribal knowledge resides in the heads of your planning head or the departments, which is again susceptible to retirements. If they retire, that it causes a bottleneck. If you don't have a next layer ready, it causes a bottleneck. So we try to address that using genetic scheduling. So here we use mathematical algorithms to find the probability, permutation combinations, the core machine learning data science of this thing, where we look into historical data. Based on that data, we have identified some 40 to 50 parameters. Again, it depends on your shop floor itself. And then based on that, we can tell you whether you have to schedule it with respect to due dates, or you have to schedule it with respect to machine occupancy and all. So how does it help? What it does is that if a new order comes in, I can easily predict what is the tentative timeline. I can start dispatching it out. So that is one of the biggest value add for this thing. So now we have talked about creating a data layer, creating digital threads out of that, integrating that thing back via different applications into the same digital thread. We have also talked about scheduling algorithms. So we have vision system which act as eyes of a manufacturing OS. So we have applications ranging from part counting, part validation, the low hanging fruits. We don't deal with microscopic detections because we require specialized hardware. For that, it's a huge investment upfront. So people are generally skeptical of investing that much on vision systems, especially when there is no, when they can easily replace it with cheap workers. So we target stuff like safety, operations, invasions, intrusion, presence detections, and all the hazardous part of the shop floors. So now all this data that we have, I believe Harish touched upon this point. We call it as a Mitra. So Mitra is our agentic layer, which sits on top of your data layer. The decision layer is imbibed within the Mitra. All your business and logic, business understanding resides within this within this AI. So since we have lots of service records, we also have kappa data for that, the RCA data, corrective actions, preventive actions, root cause analysis. So this agentic system is fed on that. It's a mixture of different SLMs which feed different permutation combinations back to an LLM, and then it gives answers based on this. So if you want to know why my line is stopped, it can tell you, it can pinpoint the exact reason, it can pinpoint the corrective action that you need to take, and it can pinpoint the preventive action so that it does not happen again. So that is the power of Mitra. So as a company, we believe in that there is no general fit for everyone. So AmiT will help you to integrate, to start your journey of building AI with us, whichever level you are. We call it, we are built to scale. Scale here means scalable. We have solutions which are cloud native. We have solutions which are on premise as well. Then we have AI ready applications. We are lean. We are able to work on whatever digital level maturity you are on, and then we are easy for modular entry level companies as well. So this all ties down to the ecosystem that we are trying to build over here. So on that thought, I would like to end this presentation saying that the future does not belong to the companies with AI, but it belongs to the factories which are most prepared for it, and we are here to help you along on that journey. Thank you.